to GTV. Today I will be showing you what the difference is between a contactor and a reversing contactor. I will also show how to wire up both types of contactors. Contactors are similar to relays in that they are an electrical switch that turns on and off when the power is applied to the coil, but are generally used for more demanding applications like motors. To give an example of how a contactor works, I will wire up my control power source to one side of a push button. I will then connect a different wire to the other side of the push button. I will use this red wire to connect to the contactor's A2 terminal. I will take my neutral wire from my control power source and connect this to the contactor's A1 terminal. This will complete the circuit, so when the push button is depressed, the coil will energize and close the contacts. This is because the coil acts as an electromagnet that draws in the metallic part from the contacts and brings them closer to another pair of contacts, thus creating a connection. I will release the push button to disengage the coil and then wire up my main three-phase power source going into the three poles of the contactors labeled L1, L2, and L3. I will also make a connection to the motor on the bottom side of the contactor marked T1, T2, and T3. How the motor is wired up should be in the manufacturer's instructions, but putting the wrong wires in T1, T2, and T3 from the motor will not harm it. Instead, the motor will run in reverse, which I will discuss a little bit later. Now when the button is pressed, the motor will spin in the forward direction. I will now remove the control power and let the motor reach a stop. I will also shut off power from the circuit breaker further up the line from the contactor so that there is no live power to the contactor. To make a reversing contactor, I will need the same type of model contactor and an interlock device. The interlock device will prevent the contactors from turning on at the same time. There are electronic, mechanical, or electromechanical interlocks available. The interlock can be placed in between the two contactors. I can wire up the second contactor's coil to a separate push button than the previous one. The second push button has one side jump to the other push button's power source, and the second contactor's A1 is jumped with the first contactor in order to reduce the need for an additional control power source. Now I will need to jump the wires on the line side, which are the wires connected to the main power source. These should be the same on both contactors, so I will jump L1 with L1, L2 with L2, and L3 with L3. On the load side, which are the wires going to the motor, I will need to jump the terminals a little differently. I will jump T1 with T3, T2 with T2, and T3 with T1. As I mentioned earlier, if there are two wires swapped together, then the motor will run in reverse. Now when power is applied to the first contactor from the three-phase coming in, it will be jumped to the second contactor. When the second push button is engaged, the coil actuates and the power will go through contacts. The power is jumped to the first contactor with two wires swapped and then to the motor. Since T1 and T3 are swapped with the power coming in, the motor will run in reverse. I will simulate this by applying power to the contactors and pushing the second push button for the motor to go in reverse. Even though the motor can go forward and reverse direction, it is best to wait for a complete stop before running the motor in the opposite direction. This can prevent the motor from drawing too much current, which could cause damage to the equipment and potential harm to people. The motor speed also does not vary in this setup and will run at the full speed it is rated for. Contactors and reversing kits, along with thousands of other products and services, are available at gelco.com.